Hey math kids, I wanted to talk about how to find your initial velocity um, if you have an equation and you know a few other pieces about your data. Um, yeah, because I was just looking at that video that I made um, with the girl throwing the ball and wondering, I wonder how hard she threw the ball in the beginning. So, a couple things to keep in mind. You need to know the units that you measured everything in. And for me, it was feet and seconds. And so, my answer is going to be feet per seconds. Other things to keep in mind is our measuring process is not perfect. And I'll explain that a little bit more and why we're allowed to make some estimates to figure out what's going on. But let's talk about this equation. So this is a math equation. This tells us the height at any given time of a projectile. This is always just negative 16. And then this V naught right here, so that little zero is pronounced naught. V naught is the initial velocity, and that's what we want to find out. That's the goal of today's video. And then H naught is the initial height. So the height when the ball leaves their hand. Okay. So, whoops, I don't know what I hit. Okay. So, let's look at my equation that I had. So this is mine. This is what my data looks like, and you can see this is my equation. We'll get to these other equations in a second. I actually don't need those. So what I noticed is in mine, I have this negative 15.2, and that may be, it's pretty close to negative 16, and so what I decided to try is just graph change it to a negative 16 and see how it changes the graph. We see that the height stays the same. The initial slope is a little bit different, and the subsequent slope is a little bit different, but I think it's close enough that we can use this as an estimate for my data, because if you look at the blue and the red, they're pretty close. So on yours, I would do the same thing. Hopefully this is close to negative 16. It should be. If not, we can talk more about it in person, and I'll have to look at your specific data. But what I'm going to do is now I'm going to take that and I'll just write that down first. So let's see, negative 16 x minus, let me see what that was, 0.6546 plus 12.6833. Okay, so this is going to be my new equation. I just changed that to a negative 16. Now, if you notice, the equation up here, the general form of this, it's in standard form. I currently have mine in vertex form, and so what I need to do is I need to manipulate it a little bit. So what I'm going to do first, I'm going to square this. So I'm going to say x minus 0.6546 times x minus 0.6546. Okay, that's just this piece. But that's the first thing I want to do. So if I square those, I do x times x, and I get x squared. And if I do x times this, I get negative 0.6546 x. And if I do this times this, I get actually the same thing. And then if I do negative 0.6546 times negative same thing. It's going to be a positive answer, and when I do that, I get 0.4285. So definitely use a calculator. Now, I have all of that, and that just represents the blue part in the box. Now, I'm going to bring down the other stuff, so I'm going to bring down this, plus 12.6833, and then I'm bringing down the negative 16. Okay, so the next thing I'm going to do, I'm just going to combine those, and if I combine those, I get negative 1.3092x. So keep in mind, I am not doing this in my head. I did this on a calculator previous to hitting record for the video. Okay, so I just brought down everything else that I didn't use, but I just combined those two. Okay, now the next thing is I need to distribute 16 to everything that's in the parentheses. Don't do it to this though. So I get negative 16x squared plus 20.9472x, and then plus 5.8273. Okay, and then I tack this on the end, plus 12.6833. And the last piece is I just need to combine both of those. So I get negative 16x squared plus 20.9472x. And when I combine those, I get positive, let's see. Oh, you know what? Sorry, I skipped a step and it messed me up. This is it. So what I did was I did negative 16 times this and then added this to get this. So this is my final. Once again, I took negative 16, multiplied it by this, got that answer, and then I added 12.6833, and that's how I got the 5.8273. When I was looking at my work, I messed that up. Okay, now just going to Desmos, we're going to double check our work. So what I did is I typed that in right there, and if you see, they're the same. So if we look at this, this is my vertex form, this is my standard form, and they're lining up as they should. And so that's how I know I did my algebra, or the simplification, correctly. Okay, now, since we have this, we can compare it to the white equation. So we have negative 16, it's right there. Our initial height is 5.8, so let's look at the graph. And that looks about right. So on my video, the girl is about 5 feet tall, but when she's throwing it, her hands go over her head. So 5.8 feet seems pretty feasible for where she let go of the ball. Now, initial velocity, we get 20.94 whatever. So I'm just going to round that to the whole number. So 21 feet per second. So that's how hard she threw the ball. She threw the ball 21 feet per second, and that's her initial velocity. So that's about it. If you have additional questions, come to Math Lab. Until then, calculator.